Alright, students, today we will start with the first chapter of the 11th standard, that is about mole concept. Right, this is a very important chapter which comes everywhere in the chemistry, and it has relationship between every physical chemistry chapter. So this is a very important topic which we are going to discuss under the first chapter of this. Now we are going to discuss about the mole concept. See, the name of this topic is mole concept, so you might have understood that we are going to discuss about something about called mole. But directly we cannot discuss about the mole. To understand about this mole concept, we need to know some fundamental concepts in the chemistry there. Let us start from the fundamentals, from the starting. So as you know that we are discussing about the chemistry. What is the meaning of chemistry there? What is chemistry at all? What we are studying in chemistry? Alright. Now you say that it is a branch of science which deals with chemicals, which deals with some experiments. But how you can define chemistry? See, chemistry is a branch of science. Chemistry is a branch of science which deals with the composition, structure, and properties of matter, right? And properties of what? Properties of matter. So this is what we are calling as the chemistry. Chemistry is a branch of science which deals with composition, means with what it is made up of, structure, and whatever structural units are there, how they are arranged there, and properties of the total matter we are discussing here. So chemistry is all about the discussion of everything about the matter in terms of its composition, structure, and properties, right? But you will ask me now, what is the matter at all? You know that the total universe has only two parts, the matter and energy. The matter is nothing but anything which is present around you, whatever you are observing around you, including you and me are a part of this matter. Anything which is existing comes under matter. But how you can define this matter scientifically? See, matter is anything which has some mass, and occupying some space. These are the two characteristic features of the matter. What are they? It should have some mass and it should occupy some space. When it is having both these characteristic features, anything can be considered as matter. Maybe it is visible or invisible. Suppose air is present around you is invisible, but still it comes under matter because it has some mass and it is occupying some space, right? I hope that you understood what is the meaning of matter. Anything, everything that present around you comes under matter because all of it has some mass and it is occupying some space. So about its properties, structure, and composition we are studying in chemistry. Okay. Let us discuss in detail about this matter. This matter can be divided based on the physical state, that I am calling it as a physical classification. Why I am calling it as physical classification? It is because only based on the physical state of this matter I am dividing this. That is why I am calling it as physical classification. Now one more classification which we are more interested in chemistry, that is chemical classification. That is chemical classification. Okay. Now we can look at this matter in two different angles. One is in terms of the physical states, another is in terms of the chemical differences. Let us finish off first this. What is the physical classification there? Based on the physical state, the matter is divided into solids, liquids, and gases. In lower classes, you have already studied that what is the basic difference between these three parts of the matter. Solids have got the fixed shape and fixed volume, and that is because of the close and compact arrangement of all the particles present in the solids like this. A compact arrangement can be seen in case of solids, and because of this compact arrangement they have got fixed volume and fixed shape. Okay. Now in liquids, what is the difference there? Again, the fundamental difference is in terms of the arrangement of the particles present in the matter, right? They are slightly away from each other, which can slide over each other. That is why they have the fixed volume but not the fixed shape. They acquire the shape of the vessel in which they are present, right? Now coming to the gases, in gases what we find is that the particles present in gases are away from each other and they are independently moving in all directions. Because of this, they neither have the fixed shape nor fixed volume. This is called physical classification, which is just based on the physical state of the matter. Let us come to our most important part of classification where we are more interested, that is chemical classification, right? Okay. According to this classification, we can see broadly three parts in the matter. The first one, the very important part of the matter, is elements. These are elements. And second part is compounds. See, we should be acquainted with these words, otherwise you will confuse again. What is the meaning of an element? What is a compound? What is a molecule? What is an atom there? So if you have clarity about all these words which we are using in mole concept, then you will not confuse again. That is why I am trying to clear all these things: elements, compounds, and mixtures, right? These are mixtures. Now let us discuss one after the another one. As I said, that the first one is the element. I will discuss in detail what are these elements there and what is its importance. Elements, if you take up. See, element is the purest form of the matter which cannot be further simplified. I will say that element is the purest form of matter. Purest form of matter which cannot be further simplified. 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 See, if you take up anything in the matter, everything is made up of these elements only due to their different combinations there. You might be observing different things around you, but everything will ultimately contain only elements there. It is something like that. I'll make you more clear about this. You have only 26 alphabets in English, But by arranging these alphabets in a different order, we are getting different words, and each word has its own meaning there. And by arranging these words, you are getting so many sentences. Sentences are giving rise to a lot of literature in English there. In the same manner, in chemistry or in matter, you take everything around you is a manifestation of these elements only. That is because of different combinations of these elements there. Suppose you take a chalk piece which is made up of calcium carbonate. If you break that chalk piece, what you will get? Ultimately you will get finally calcium, carbon and oxygen. This is the final composition of the chalk piece, calcium carbonate. You cannot obtain more simpler forms than these at the end of all chemical reactions there. You can't get more simpler forms of that chalk piece than this. That's all. We end here. So like that, everything if you decompose in the matter, ultimately we will end up with elements only. I cannot divide calcium into more simpler forms. It is the simplest thing. It is the most purest form of the matter is called as element. Right? So I can also call, in other words, that element is a fundamental unit of matter. The total matter is made up of by the combination of elements there. That is why, just like for a living organism, the cell is a fundamental unit, and for the matter, anything in the matter, the fundamental unit is element only. Right? So that is the importance of element. Element is the purest form of matter which cannot be further simplified. Now, these elements can have different properties, and based on these properties they can be divided into, we have the metals, non-metals and metallites. The basic difference between a metal and non-metal is that metals reflect the light. That is the reason they have luster. Non-metals cannot reflect the incident light. That is why they don't have luster. But metalloids are having the both properties of metals and non-metals there. They are mixed elements, we can say. So totally we have in chemistry 114 elements there, and everything that we are discussing in chemistry is from these 114 elements only. Out of them, 98 elements are naturally occurring. The 98 elements are naturally occurring elements, and remaining are artificially synthesized elements there. The naturally occurring elements. Okay, this is all about elements. I hope that you understood what is an element and what is its importance, right? Now coming to the second part of the matter according to this chemical classification, that is compound. What is this compound? Let us see. The compound is nothing but a chemical combination of two or more than two elements in a fixed ratio by mass. I repeat again that compound is a chemical combination. It is nothing but a chemical combination. I will tell you the meaning of this chemical combination. It's a very important thing. That what is the meaning of chemical combination, I will tell you. Chemical combination of two or more than two elements. Two or more than two elements. Or more than two elements in a fixed ratio by weight. In a fixed ratio by weight. In a fixed ratio by weight is called as compound. Is called as compound. Right. Now let us discuss about these compounds. I said chemical combination. What is the meaning of this chemical combination and what is the fixed ratio by weight? Let us discuss. Imagine that there is one element hydrogen I am taking and another element oxygen taking, and both of them are combining with each other in a chemical reaction and giving rise to water. We are very much familiar with water, which is also a chemical. Now the first thing you should remember that this hydrogen and oxygen ratio by mass is always fixed there. In every compound of water, we will find that the same ratio of the masses of hydrogen and oxygen there. It is not different. Suppose you take here that 2 grams of hydrogen we have and 16 grams of oxygen we have. This is equal to 1:8 ratio. It means that at this stage I can tell you one thing, that in every water molecule, the ratio between the hydrogen and oxygen fixed, that is 1:8. This is what called as a fixed ratio by weight. Now let us discuss that what is the meaning of this chemical combination there. Okay. Answer to this simple question, that in H2O, okay, which I am calling as a compound, is hydrogen present or not? Yes, hydrogen element is present in the H2O. Hydrogen is present. That is the reason the formula we are writing H2O. Oxygen is also present there. But does H2O exhibits the properties of hydrogen? No. Does it exhibit the properties of oxygen? No. It is neither exhibiting the properties of hydrogen nor the properties of oxygen. And it is individually exhibiting its own properties. Even their physical states also not same. Water is a liquid at room temperature. Hydrogen and oxygen are gases at room temperature. So none of the properties H2O is resembling with the hydrogen and oxygen elements there. I am telling that H2O is containing hydrogen and oxygen, but it is not exhibiting any properties of hydrogen and oxygen elements. It is because whenever there is a chemical combination, this is what called as chemical combination. Whenever there is a chemical combination between two elements, they lose their identity. In H2O, there is no identity for hydrogen. There is no identity for the oxygen there. Altogether, individually, this H2O compound has got its own identity. And this is what called as the chemical combination. The meaning of chemical combination is this one. Whenever the constant elements are losing their identity because of the combination, then that is called as a chemical combination then. Right? Now, elements are giving rise to compounds. How? By chemically combining. You know the meaning of chemical combination now. By chemically combining in a fixed ratio by weight, and they are called as compounds. It is something like that, again our old example. So many alphabets are combining with each other in different orders and giving rise to so many words. It is, I can compare something like elements are alphabets and our compounds are like words. Right? Right. I think it's very clear to you now. This is what called as compounds. Now let me tell you one important thing about these both elements and compounds there. That is, both elements and compounds are pure substances actually. Why they are pure substances? Okay. Why they are pure substances? Because you take any element, it is made up of identical particles, same type of particles are there, and if you take any compound, it is also made up of same type of identical particles there, right? The particles possible to be present are maybe atoms, which we are calling as a fundamental structural units in elements and compounds there, right? What I am trying to tell here is that that these elements and compounds contain identical particles. They will contain the identical particles or identical structural units. Let us take them as identical structural units. They contain identical structural units with which they are made up of. There is no difference at all. That is why in other classification will be considered under the pure substances there. This I am giving because the next part of this matter which I am going to discuss, that is mixtures, is not considered as the pure substance. It is because it is not containing all identical structural units. Structural units means with which it is made up of. All those structural units are not identical, not same. That is why it is called as the non-pure substance there. How to define a mixture there, right? Let us see the definition of mixture there. You see that the physical combination, I am using the word physical combination. The physical combination of two or more than two elements or compounds, you see both of them, are both, is called as mixture. It is called as mixture. Let us see in detail about this mixture there. So from the definition you might have understood that a mixture may contain two or more than two elements, or it may contain the two or more than two compounds, or elements and compounds, both of them together. Suppose I will give you a very simple example that air. We know that what is the composition of air. Air is containing oxygen, nitrogen and carbon dioxide. These two are elements, right? And this is a compound, because a compound is always formed due to combination of elements there. It is formed due to the combination of carbon and oxygen, right? Is it clear? So two elements are there and one compound is present in the air, but they are existing together. Remember here the difference between previously what I said, chemical combination and the physical combination here. In a chemical combination, the constituent units which are participating in that chemical combination lose their identity, but in a physical combination they retain their identity. Inside the air, oxygen has got its own physical and chemical properties, nitrogen has got its properties, carbon dioxide has got properties. None of them have their identity. They are retaining their identity, and that is the reason it is called physical combination there, right? And it is called as mixture because it is a non-pure substance. You see, this is one type of particle, this is another type of particle, this is another type of particle. All particles with which it is made up of is not identical. They are not identical. But what we have seen in case of the compounds and elements, whatever with particles with which they are made up of, those particles are identical or same. And depending on the physical state, these mixtures can be again divided into a very simple classification: homogeneous mixtures, and heterogeneous mixtures. Homogeneous and heterogeneous mixtures. In homogeneous mixture, all the different components are present in the same phase. Again, our air is example for this. But all the components in a mixture are not in same phase, then we will call it as a heterogeneous mixture. Example can be taken as sand. It is containing so many sand in water. If you take sand in water, the sand is present in water, but it is existing. They are existing in two different physical states. That is called heterogeneous mixture there. And even you can take all liquid solutions as example for homogeneous mixture also there. Now these are the basic parts of the matter according to this chemical classification. We have seen that according to this, matter is divided into elements, compounds, and mixtures, in which the purest form is elements, and they wanted to know that what is present and with what these elements are made up of, right? You know that these elements are made up of the smallest particles called atoms, and this was given by Dalton's atomic theory. Dalton's atomic theory. Dalton's atomic theory. See, Dalton is the first scientist who has used this word atom for the first time. He has introduced the word atom. Let us see what is the meaning of atom and where are they present. Everything we will learn here. What is Dalton's atomic theory? Right. First of all, let me tell you that the word atom was by Dalton, which means that atom is meaning indivisible particle. Indivisible particle. Indivisible particle. A means no, term means cut. So the meaning of atom is itself indivisible particle. There the basic principle, basic theory of the Dalton's atomic theory is around this indivisibility of atom only. Now you see that what Dalton is saying, that elements are made up of with tiny particles. According to him, all elements contain tiny particles. All elements contain tiny particles, and these tiny particles are called as atoms. Right. Number two, atoms are indivisible. As I've already told you that according to him, atoms are indivisible. We cannot divide the atom up to the Dalton's atomic theory. Right. Atoms present in an element. Atoms present in an element. Present in an element. Present in an element are identical. There is no difference between them. Are identical, but they differ. But they differ. But they differ from the atoms present. From the atoms present in other elements. In other elements. So what is trying to tell is that if you take one element there, and all these atoms present in that one element are identical in all aspects, maybe in terms of their mass, maybe of their chemical behavior, everything is identical in an element. But if you compare these atoms with the atoms of other element, they differ. Okay. Now, and one more point he has given, that atoms can be neither destroyed. Atoms can be neither destroyed. Can be neither destroyed. Atoms can be neither destroyed. Neither destroyed nor created. We cannot form the atoms from any simplest things there, and we cannot further break the atoms into any simple things there. So that is why we neither destroy, we cannot either destroy nor we can create them, right? The last point of this theory is that two or more than two atoms, two or more than atoms, two or more than two atoms, two atoms combine with each other, combine with each other, combine with each other to form compound atoms, to form compound atoms. Nowadays we are calling these compound atoms as molecules, but in those days Dalton called them as compound atoms, right? So they are nothing but molecules. But except that one point, that is atoms are responsible for chemical properties and atoms are participating in chemical reactions, all the postulates of the Dalton's atomic theory experimentally proved to be wrong. Because if you take up the first thing, that atoms are present, atoms are invisible there, atoms are indivisible there, atoms are indivisible, right? I wrote here atoms are indivisible. Okay, but it is found that atoms still contain very small particles like electron, proton and neutron, which we are calling as fundamental particles there. Atoms present in an element are identical, but they can be differ also in terms of isotopes. But atoms can be neither destroyed nor created there. We know E is equal to mc square. The matter can be converted into energy, energy can be converted into matter. So this is also proved to be wrong there. So like that, majority of the postulates were not able to withstand in science. But one thing he has given is very correct, that is atom is the smallest particle of the matter, smallest particle of the element, right? If you take up the atom, how we can define this atom? Atom can be defined as smallest particle of matter which may or may not exist independently, may or may not exist independently, may not exist independently. Right? See, there is one problem with atom. No doubt that the smallest particle of the matter is atom only. But the problem is atoms cannot exist independently. They always try to convert into some other things. What are they? They are molecules. Since they don't have independent existence at room temperature, they cannot exist there, right? Except few atoms there. But in which form the particles will be there, anything you take at room temperature, they are molecules. The word molecule was first introduced by Avogadro. According to Avogadro, this is the basic difference between atom and molecule. Then what is a molecule here? Molecule is also smallest particle of matter. Smallest particle of matter, but the difference is that which can exist independently, which can exist independently. This is the basic difference between atom and molecule, right? Since atoms are not existing at room temperature there, and only molecules are existing at room temperature everywhere in every substance, let us know more about these molecules, right? Generally, a molecule is a combination of two or more than two atoms, or else a single atom also can behave as a molecule if it is having independent existence there. It is not compulsory that always a molecule should have two or more than two atoms. Let me tell you here that a single atom can also act as molecule. It is not compulsory that a molecule should contain two or more than two atoms. Such situations, they are called monoatomic molecules there. Okay. But only required condition for a molecule is that it should exist independently. It should have some stability there. It should not participate in chemical bonding. It should not participate in chemical reactions there as it is stable. But atoms are not like that. They are participating in the chemical reactions in a chemical bond because they are not stable there. If you know more about these molecules, that these molecules can be divided into two types. They are homoatomic molecules. Homoatomic molecules. What are these homoatomic molecules? I will discuss. Let me give you the other part of these molecules, that is heteroatomic molecules. Heteroatomic molecules. The name itself indicates that homoatomic molecules contain same type of atoms in that molecule. Suppose you take O2 is a homoatomic molecule. Take P4. P4, it is made up of 4 phosphorus atoms. O2, it is made up of 2 oxygen atoms there. Right? S8, it is made up of 8 sulfur atoms there. Like that, anywhere a molecule is formed due to the combination of same type of atoms, we will call them as homoatomic molecules. Okay, I will take up some more molecules like heteroatomic molecules. Take up carbon dioxide, then 2SO4 you take. Anything, all other chemicals you know, you can take up that sulfur dioxide you take. They are called as the heteroatomic molecules. Why? You might have understood by now that they contain atoms of different elements. See, carbon and 2 oxygen atoms are present. They are not same type of atoms there. That is why I am calling them as heteroatomic molecules, right? Let me tell you a very important point here is that everywhere I said molecules are present there in the nature generally because they have independent existence. Where are these homoatomic molecules are present there? Always homoatomic molecules will be present in the elements. Remember, elements contain homoatomic molecules. And where are these heteroatomic molecules are present there? Compounds contain these heteroatomic molecules. So both elements contain molecules and compounds also contain molecules. But what is the basic difference there? The molecules present in elements are homoatomic molecules. The molecules present in the compounds are heteroatomic molecules there. That is a difference in terms of molecules then. Right? Now you have understood about the different type of molecules and where they are present there. Now here let me tell you one simple definition called atomicity, which is very important in our future discussion. That is, what is the meaning of atomicity? Let us understand. Atomicity is nothing but a number of atoms present. Number of atoms present. Number of atoms present in a molecule is called as atomicity. Suppose you take the carbon dioxide. How many atoms are there? 3 atoms are there in each molecule there. That is why atomicity is 3. Suppose you take H2SO4. This is number of atoms are equal to 5 plus 2, 7. Just to count the number of atoms present here then. Suppose you take the P4 molecule. P4 molecule. How many atoms are there in this molecule? That is 4. Simply atomicity is nothing but number of atoms present in a molecule, that is called as atomicity. It is a triatomic molecule, it is heptatomic molecule, it is tetraatomic molecule. Simple thing, right? This is a very important thing in future in our calculations there. Atomicity is nothing but number of atoms present in a molecule. Okay. Now, based on atomicity, based on atomicity, based, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 150 151 152 153 154 155 156 157 158 159 160 of molecules, atomicity of molecules, we can have the different elements. Elements can be classified as follows. This I am giving because you should know that which element is containing what type of molecules there. Otherwise, we will confuse between taking atomic weights and molecular weights there. What is a molecular weight we should take? What is atomic weight we should take? We will confuse. Generally, students sometimes in place of atomic weight, they'll take molecular weights. In place of molecular weight, they'll take atomic weights, right? That is why simply you should know that which elements containing what type of molecules in a simple classification. That is elements containing monoatomic molecules. You see here a single atom is itself acting as a molecule. Monoatomic molecules. Containing monoatomic molecules. Carbon, all metals, and noble gases. So these are the elements which contain monoatomic molecules. Any metal you get and any noble gas you get and carbon, these are all molecules containing the single atom, right? Now if you take up second category, that elements containing diatomic molecules, Here we will take up that most of the gaseous elements are containing diatomic molecules: hydrogen, chlorine, fluorine, nitrogen, bromine, iodine. Right. They are called elements containing diatomic molecules then. Now third one is elements containing triatomic molecules. Elements containing triatomic molecules. The only example for this is ozone, which is containing triatomic molecules. Now fourth one, elements with tetraatomic molecules, right? Tetraatomic molecules. These are the elements which contain tetraatomic molecules, that is P4, AS4, arsenic, and antimony. Then if you take up the last one, elements containing octatomic molecules. Here we have only three elements, that is S8, selenium-8, and tellurium-8, right? Now if you remember these elements with their atomicity, this is a simple way of identifying the atomicity of different molecules, especially in the elements there, okay? Now I will move on to the very important part of this mole concept, that is atomic weight. What is this atomic weight? Let us see. See, the weight of a single atom is called as atomic weight. But can we able to find out the atomic weight by using any balance or any instrument? It is possible practically because we can't see the atom. How we can separate it and we'll put it on a balance and weigh what is the weight of that atom there. Separation is difficult. Even if you separate, finding the weight of a very small atom is practically impossible. So one thing, take it for sure that finding atomic weight experimentally or manually difficult. Then what we will do? How we will express this atomic weight then? See, this problem was solved by the Avogadro's hypothesis. Is a very simple theory you might have studied in your lower classes. That again I repeat that. What is this Avogadro's hypothesis then? Avogadro's hypothesis. This Avogadro's hypothesis made finding the atomic weight or defining the atomic weight simple. What is this Avogadro's hypothesis? You know that at constant pressure and temperature, equal volumes of all gases contain equal number of molecules. Right? Suppose if you take hydrogen and oxygen at constant pressure and temperature. Let their volumes are V and V, same volume also I am taking. When you are taking the same volume, they will contain equal number of molecules there. It will contain n number of molecules. It will also contain the n number of molecules there. Right? When both of them are containing the equal number of molecules, their mass ratio, if you take, their mass ratio containing the equal number of molecules will be equal to 1:16. Or else you take the volume weights of the equal volumes of hydrogen and oxygen there, that is also 1:16 only. Okay. Equal volumes of hydrogen and oxygen weights are 1:16 ratio. It means that equal number of molecules of hydrogen and oxygen also will have the weights in the ratio of 1:16. Okay. Then I will take up here one molecule here and one molecule here. This is also equal molecules, only this number if I take, but still the ratio is same. From this, what we can derive, let us see. Right. So what is the conclusion that I have come to? That is one molecule of hydrogen and one molecule of oxygen, the ratio is between them is 1:16. Can I tell that one hydrogen molecule is 16 times lighter than oxygen. So lighter than oxygen. Either way, I can also take that oxygen is 16 times heavier than the hydrogen there. Now both of them contain same number of atoms in them. It is a diatomic molecule. It is also diatomic molecule. By using Avogadro's hypothesis, we can determine even atomicity of the molecules also there. This is a diatomic molecule. It is also diatomic molecule there. Both of them contain same number of atoms there. Can I take that the ratio between the weight of one hydrogen and atom and the weight of another oxygen atom is also will be in 1:16 ratio. It means that that atomic weight of oxygen is 16 times greater than the atomic weight of the hydrogen. Like that, we can compare all other elements with the weight of hydrogen, and this is what called as relative atomic weight. Those atomic weights which are given by comparing the weight of the atoms with a standard unit called as the relative atomic weights. So initially they have taken hydrogen as the fundamental unit or fundamental element to define the atomic weights there. But the problem when you take hydrogen is that we are getting the atomic weights, relative atomic weights of majority of the elements in fractions. Then later on they have taken oxygen as a fundamental unit there, but even it has some problems. Now that element we are taking as a fundamental unit to define this relative atomic weight is the C12 isotope we are taking here. C12 isotope we are taking as the basis or a reference element to define the relative atomic weights. So one thing is clear that we cannot find out the exact atomic weights directly. Then generally we will take the relative atomic weights, right? Relative atomic weights. This for simplicity I will take up that RAW. How we can define relative atomic weight? As the name itself indicates, it is a relative value. Okay. The weight of an atom. The weight of an atom by 1/12th weight of 1/12th weight of 1/12th weight of C12 atom. The 12 indicates mass number of the carbon there, is called as atomic weight. Since it is a ratio, it is not having any units, but generally this is expressed in the AMUs. What is this AMU there? AMU stands for atomic mass unit. This stands for atomic mass unit. Atomic mass unit, which is used to measure the masses of the atoms there. Atomic mass unit. The experimentally calculated value of the 1 AMU in grams is equal to, that is 1.6604 into 10 to the power of minus 24 grams, right? Just remember this value of AMU in grams there. Now let us come back to this. I will come back to the relative atomic weight. What is the relative atomic weight is indicating? Relative atomic weight is indicating weight of a single atom expressed in AMUs, which is nothing but this many times it is heavier than 1/12th weight of C12 atom, or this many times it is heavier than 1 AMU. Because here I should tell you that 1 AMU is nothing but equal to the 1/12th weight of equal to 1/12th weight of C12 atom. 1/12th weight of C12 atom. Right? Now if you want to convert this weight of one atom, which is expressed in AMUs, if you want in grams there, we will call it as the absolute atomic weight. What is this absolute atomic weight? Let us see. Absolute atomic weight. This is AAW, let us take. Now, whatever relative atomic weight I have, that is in AMUs. Now I am converting this into grams by multiplying with 1.6604 into 10 to the power of minus 24 grams. So what is the difference between this and this relative atomic weight and absolute atomic weight? Absolute atomic weight is the weight of one single atom expressed in grams, whereas relative atomic weight is the weight of one single atom expressed in AMUs or atomic mass units there. But both of them are not having practical usage. We cannot use them practically calculations. It is because when chemists are doing experiments, they never deal with a single atom or single molecule there, which is not possible practically. That is why they always discuss in terms of the moles. They always speak in terms of the number of moles. That is why the third atomic weight, which is in practical usage, that is the gram atomic weight. That is gram atomic weight. That is gram atomic weight. This I am calling as the GAW. What is this gram atomic weight? We will discuss. Now I am taking the weight of one atom expressed in grams, that is nothing but, okay, can I write this as the one single weight is expressed in grams, I will take as the absolute atomic weight. This I am multiplying with the Avogadro number of atoms, 6.023 into 10 to the power of 23. You will come to know that why we are taking Avogadro number there. But if I am multiplying this absolute atomic weight with this number, Avogadro number, that is giving you gram atomic weight. Simply I can tell you that absolute atomic weight is a weight of one single atom expressed in grams, whereas gram atomic weight is not the weight of single atom. Remember that it is the weight of Avogadro number, or this many number of atoms there is a weight of 6.023 into 10 to the power of 23 atoms expressed in grams. Suppose if you take a simple example that the relative atomic weight of oxygen is equal to 16 AMUs. Suppose 16 AMU. What is the meaning of this? It is indicating that the weight of a one single oxygen atom is 16 AMUs. Okay, one single oxygen atom when compared to the 1/12 weight of C12 atom there. But if you want to find out the gram atomic weight of oxygen, you can get it easily. That how? By taking the same relative atomic weight and expressing this in grams there. Only you are changing this AMUs into grams, but lot of difference in their meaning. What is that? The 16 grams is always indicating the weight of, let me tell you one important point here is that if I am taking this absolute atomic weight divided again into RAW into this 1.6604 into 10 to the power of minus 24 and into 6.023 into 10 to the power of 23. This value gets cancelled. and finally we will get here that RAW expressed in grams only. So gram atomic weight is nothing but relative atomic weight expressed in grams finally. So this 16 AMU is a relative atomic weight and 16 grams is the gram atomic weight of oxygen. So it is the weight of Avogadro number or 6 Avogadro number, weight of Avogadro number of oxygen atoms. Avogadro number of oxygen atoms. Right. Now we shall see the gram atomic weights of some of the elements we come across in our calculations here. Gram atomic weights of some elements. Gram atomic weights of some elements are like this. Suppose you take hydrogen, then this is 1 gram, then helium, it is 2 grams, then lithium 7 grams, chlorine 35.5 grams. Now if you look at this chlorine gram atomic weight, what we find is the fractional value we have got. Why do we get fractional atomic weights there? It is because of the presence of isotopes. Due to presence of isotopes, due to presence of isotopes, we will get the presence of isotopes, we will get the fractional atomic weights. That is where the correct definition of the atomic weight to atomic weight or gram atomic weight would be there. It is the ratio between the average weight of the one atom. So correct thing that we should take up in such situations is that relative atomic weight when you are taking. Suppose if that particular element is containing the more than one isotopes, then we should take the average atomic weight, average atomic weight of one element, of one atom, or average by 1/12 weight of C12 isotope, C12 atom. See, let me tell you that why we are getting this fractional atomic weights like chlorine. In case of chlorine there, see, chlorine contains two isotopes, that is Cl35 and Cl37. If you take the total chlorine element there, what we find is that it is 80% of the, this is called percentage of abundance there, 80%. This is, let us take it as the 75% of the chlorine 35 is present, and chlorine 37 is 25%. It means that if you take 100 chlorine atoms, out of them 75 will be having the mass number 35 and 25 will be having the mass number 37. Okay, then which atom you will take, either chlorine 35 or chlorine 37? We should not take neither of them, but you should take average of these two there, and that is what giving you average mass of atom. Average mass of atom, how you will find out? the percentage of abundance of one element, the percentage abundance of one element, either rather we can take that fraction of abundance. I am taking up here that fraction of abundance or percentage of abundance. What is the percentage of abundance of this chlorine there? 75. Now its mass number is 35 plus 25% of the atoms are having the 37. Then the total number of atoms possible 100 if you take. What we are getting here. So on simplifying this, you will be getting the 35.5 grams of 35.5. Okay, if it is a gram atomic weight, then we can write it as the in grams there. Okay. Now this is the reason that why we are getting the fractional atomic weights. But how do you get the average mass of an atom then? Average mass of atom can be calculated by the summation of the fraction of abundance or the percentage of abundance there, that I will indicate by using the only percentage here. Percentage of abundance of different isotopes into their mass numbers by 100. So this will give us the average mass of an atom, where most oftenly we will get the fractional values, right? In the next class we will discuss about what are the molecules and what is molecular weight. Then we will proceed to the mole concept, right?